Hi, today we're going to go over the last lesson of the chapter, which is 10.6, Perimeters and Areas of Similar Figures. So a quick recap of the symbols for area and perimeter. Make sure you know those. Okay, so let's find the perimeter of the baseball field. So to do that, we're just going to take 90 times 4. And that is 360. And so the perimeter of the softball field, 60 times 4 is 240. Okay, so the area of the baseball field, we would actually do 90 times 90. And so 90 times 90 is 8,100. And the softball field, 60 times 60 is 3,600. Okay, so why did we do this? Okay, so first of all, let's simplify these down. Now, if you have a yellow calculator, you could type this into the use the numerator denominator button, type it in, and it simplifies it for you. So this simplifies down to 3/2. And the second one simplifies down to 9/4. Okay, so baseball player has to run how many times longer than a softball field? Well, this reduces, now, obviously when you run, it's the perimeter. So we're going to be looking up here. And so the baseball is 1.5 to 1. And what I did is I just simplified it down even more. So they have to run 1.5 times as long as the softball player. Now, backing up the problem though, I want you guys to notice that these two numbers are not really equivalent, right? I mean, 3/2 is 1.5, 9/4 is 2.25. How are these numbers related? And that's something we're going to talk about today, because we're going to use the perimeter and the area as our last two ways that we can write proportions. Okay, so we can come back to that. So here's the two theorems of the day, and they're the last two of the chapter, but people always mess them up. Okay, I'm just warning you. Okay, the ratio of the perimeters of two similar polygons is equal to the ratio of the corresponding sides. So what this is saying is you can just use the perimeter like you do a side length, or you did the altitude. You just do it like normal, okay? And we will practice that. For theorem 48, as you can see, there's a key word here. The ratio of the area of two similar polygons is equal to the square of the ratio of the corresponding side. All right, let's go back. These two numbers that I have like boxed, they're not equal. But it says if you square the side, which a perimeter you treat the same as a side length, it would equal the area. And it works, right? Because 3 squared is 9, and 2 squared is 4. So it works. All right. So let's practice a few of these questions. Find the area and the perimeter of the triangles, and then set out proportions using theorem 48. Okay, so let's find the perimeter and the area of each one of these. All right, so for perimeter on this first triangle, let's just call that my first triangle. Let's just add it all together. 15 plus 12 plus 9. The perimeter is 36. And I'm not going to worry about units, 36 units. Now, for the area, it's 1/2 base times height. My base and height make this right angle. So 1/2, 12 times 9. So 1/2 times 12 times 9 is 54. All right, let's do the same thing for the next one. 4 plus 3 plus 5 is 12. And my area is 1/2 3 times 4. And what is that? 6, right? Yeah. Okay. So let's practice this. Now, it says that we can set up the side lengths. So 15 corresponds to 5, 9 corresponds to 3, and 12 corresponds to 4. Now, perimeter should have the same ratio. So these are the sides, if I can spell sides. The perimeter is going to be 36 to 12. Now, let's check the scale factor. If I were to reduce all of these, do you get the same thing? Well, 5 goes into 15 3 times, 3 goes to 9 3 times, 4 goes to 12 3 times, and 12 goes into 36 3 times. So they all have the same scale factor. Great. Now, here's where it gets tricky. The area is 54 over 6, right? Now, 54 over 6 is 9, which is not the same thing. Okay, so to use our new theorem, which is theorem 48, you can take any of the sides or the perimeter, and let's just use the perimeter. You take the area, so this is the perimeter, this is the area, and what you have to do is you have to take the perimeter and square it. Okay, so 36 squared, it might have been easier if I used one of the smaller numbers on the sides. I get 1296, and 12 squared is 144. Okay, now moment of truth. After I do this, because this is really that, do they simplify to the same thing? 54 over 6, I already told you, is 9. So 1296 over 144 is, double check me, I get 9. Okay, now some people ask, now this always works, okay? And so there's going to be unknowns and you have to like cross multiply and solve it. Some people always ask me, well, instead of squaring one side, can I square root the other side? And the answer is yes. If you would rather square root the area side, that's a possibility and that will work. And sometimes depending on where the X is, it makes more sense to do that. And we're out of notes, but I'll just make up a problem. Okay. All right. What's going on with my keyboard? All right. So here's a triangle. So call that X. And we're going to say the area is 15. And here's another triangle. And let's call this 20. And that the area is 40. Okay. Now, I would highly recommend you don't say X over 15 equals 20 over 40, because you need to compare triangle to triangle, area to area. So you have each proportion separated so you could square one of them, because you will mess it up otherwise. Okay, so side to side, triangle 1 to triangle 2, and then area of triangle 1 to the area of triangle 2. Now, to make this equal, you have to square the side length one. Okay, so this is x squared equals 400 equals 15 over 40. All right, so it's cross multiplication time. 400 times 15 is 6,000 equals 40x squared. Now I'm going to divide by 40, and x squared is 150, and then you have to square root that. So my calculator gives me this answer, and as a decimal, it is 12.2. Okay, now, moment of truth. Let's try to do this a different way. So let's go back to this problem and say you have 15 over 40, but this time you want to square root that side. Well, okay. I don't know if this is going to work very well. Because my instinct would be to get rid of the square root and times both sides like this. And then we're back to the original. All right, so I don't think I'm going to rework it that way. I don't like it. Okay, now I am going to change the question though. Okay, I want to move the x. Let's say you move that up here and now the area is x. Let's try it. So this was example 1, and let's try example 2. So the area of the first figure, the side length of the first figure to the side length of the second figure, the area of the first figure to the area of the second figure. Now, the one that's not the area, you have to square it. Okay, so 15 squared is 225, and 20 squared is 400. Okay, and so we're going to have to cross multiply. So 400x equals 225 times 40, which is 9,000, and divide by 400. And that is 22.5. You might have predicted that because here to here, you can see you just took off a 0. So here to here, you would just move the decimal back. So it is kind of different depending on if you're solving for the area or side length. And guys, when I say side length, this side length could be the perimeter, it could be the altitude, because you treat them all the same. Okay. And that is it for our last lesson. Let me know if you have any questions. Thanks.